So this is 4.3, B as in boy, in elementary algebra, and we're starting with multiplication and division of numbers written in scientific notation, and this can be handy. When we have something like 4 times 10 to the 7th times 2 times 10 to the negative 4th. Alright, so we have something written in scientific notation. What we do, again, we multiply the numbers, make a times, make a 10. Okay, that will always be the case. And then what we do, because we're multiplying, is we end up adding our exponents. So 7 plus negative 4 is a 3, and we're done. Okay? When I have something like 9.6 times 10 to the 12th divided by 3 times 10 to the 4th. What I do is I divide 9.6 divided by 3, and when I do that with my calculator I get 3.2. I make my times 10, and then I subtract these. So remember, in division you subtract, in multiplication you add. Okay, that's it as far as multiplication and division of scientific notation. So the next section is on addition and subtraction of monomials. We already talked what a monomial is, but one of the things as far as adding and subtracting, you can multiply anything you want. You can divide anything you want. But adding and subtracting, there are a couple rules to follow. And those rules are that the variables have to be the same. So if I'm adding those, I can't say x plus y. I cannot combine those because they're not the same. The only thing I can add are if the variables are the same number. The other thing that's true is the number up here has to be the same. Okay? That has to be the same. If this were a 3, I couldn't do anything, but since they're 2's, I can do something. So notice what happens when you add variables. You don't do anything with them. They stay x squared. It's kind of like saying 1 quarter plus another quarter equals 2 quarters. So 1x squared plus another x squared equals 2x squared. If I have 2x squared plus 3x squared, it's just like quarters. 2 quarters plus 3 quarters is 5 quarters. So 5x squared. So this will never change in addition and subtraction. And that's the key. These have to be the same. This has to be the same. And then you just add the numbers in front of it. And that's pretty much the only rule for adding and subtracting monomials. So if I have 3x squared and I want to add 15x squared, I'm going to get negative 3 plus 15 is 12x squared. If I have 9x squared y, and I'm going to subtract 20x squared y, again my variables and the exponents on the variables are the same, so I can do this. And I get that. If I have 5x squared plus 8y squared, I can do nothing. I have to leave it alone because I have two different variables. So this is example number 11, and let's look at this. Now this is why I make you take notes, is there is so much stuff to remember. Okay, first thing to remember, when you're multiplying anything or dividing, you're going to do your division last. You're going to cross this line last. You're going to do what you can up here to simplify. You're going to do what you can down here to simplify. Then you're going to cross the line and divide. You're going to compare these two. This is already simplified. There's no multiplication, there's no plus or minus between monomials, so that's as simple as you can go. But we can multiply that. And when we do that, we get 18, 6 times 3. Our x is 4 plus 7, because we add when we multiply, and our y is 1 plus 5. Now we have one term or monomial on top, and we have one on the bottom. Now we can divide. 18 divided by 9 is 2. We're going to take these 5, and we're going to take 5 there, and that leaves me with an x to the 6th. I'm going to take these 2, and I'm going to take 2 from there, and that leaves me with 4. So I'm going to have y to the 4th, and I'm done. So let's look at example 12. Let's do the same thing with scientific notation. So that's to the 5th. God, that print is so little I can't read it. Okay, all over. That. So again, we're going to do we're going to simplify this first, because we have two things that can be multiplied, and then we'll divide. So we're going to multiply 6.8 times 3.9. And I get 26.52, and then I make my 10 times 10, and then I'm going to add this and this together. 5 plus negative 7 is negative 2, and then that is going to be over 7.8 times 10 to the negative 4. So now I'm going to divide these two. 26.52 divided by 7.8, and I get 3.4, and then I make my times 10, and then I subtract negative 2 minus the negative 4, which that's going to end up being a plus. So I end up with 3.4 times 10 to the negative 2 plus 4 is squared, and that ends up being my answer. So example number 13, what we're going to do here is, again, we're going to simplify things before we combine, before we add, because in PEMDAS we add and subtract last. So let's go ahead and see if we can simplify this one, and then we'll add. So we have 14 over 2, which is 7. Let's just go ahead and draw a line. And I'm going to get rid of 2 of those and 2 of those, so that means I have an x cubed on top and a 1 on the bottom, which you don't even have to show, but put it there anyway. Okay, 15 over 3 is 5, and we have a 1 on the bottom. And we have 5 of those, and we'll take 5 of those. That means we have 3 left. So now what we're going to do is add those. And why can we add those? Because we have the same variables and the same exponent on the variable. If that wasn't the same, we couldn't do that. Alright, so let's jump to example number 14 and 15. 14 says if we have x squared and we're going to multiply it by 1 minus 6 over x. First thing we're going to do is we are going to distribute this x squared here and here. So x squared times 1 is x squared minus x squared times 6 is 6x squared, and that's going to be over x, because this is a 1 under here, and 1 times x is going to give me x. Okay, so I've got that. Alright, now what I can do is I can cancel this x with one of these, and I'm left with 1. So I end up with x squared minus 6x for an answer. Now if I have AB, which is example 15, and I have that, I'm going to distribute again. This times this is going to be AB times 1 over b, because there's nothing to multiply that by, so because I multiply those two. And now I'm going to multiply AB times that, minus AB times 1, can't do anything there. This times this is just going to be a. Now, notice what I can do here. I can cancel this b with this b, and this a with this a. And then I'm left with a minus b. One of the things that's very, very important is, let's say that I had AB over A. Now let's AB over C minus AC over A. Okay, very important here. I cannot cancel this C with this C because I have to cross a minus sign to do that. You can never cancel across a plus or a minus sign. If these were multiplication, I could do that. But if they're a plus or a minus, you cannot cross those out like that. But if I had an AB over C times AC over A, there's no addition or subtraction sign separating the two, so I'm not crossing an addition or a subtraction sign. Very important to remember. Last example of this lesson, example 16, we're talking about a rectangular solid, and it's a little story problem here. And so let me draw my rectangular solid here. And it says that it is twice as long as it is wide. Well, how wide do you want it to be? We don't know anything about how wide it is. We know that it's twice as long, so we're going to make our width x since we don't know anything about that. And we know that the length is going to be 2 times x. What else does it say? It's 1/2 as high as it is wide. So it's x wide, so height is going to be half of x. Write an expression for the volume. Well, what is the volume of a rectangular solid? Length times width times height. So my length is 2x. I'm going to multiply that by the width, and I'm going to multiply that by the height. It doesn't ask me to solve it. All it asks me to do is write an expression. Okay, if you want, you can multiply all these together. So we get 2x squared times 1/2 x. And what is half of 2? 1. What's x squared times x? X cubed. So we can take that 1 away, and our volume for that figure is x cubed. So you could leave it this way, or you could keep going and write it that way. And that's it for lesson 4.3.